Everyone. Today we will discuss some questions from electrochemistry. This is a previous year question collection. So we will discuss from this. Okay. See, read the passage given below and answer the questions that follow. Here one figure is given. See, zinc is connected with a silver plate, and here a salt bridge is given. Okay. So zinc is dipped in Zn2 plus solution, silver is dipped in Ag plus solution. Okay, so here what is the question is silver plate anode or cathode? Okay, so how do you understand that silver plate is anode or cathode? So here we should know something. Here the metals are zinc and silver. Okay, and here reduction potential values are not given. Usually we can predict which is anode and cathode from the standard reduction potential value. For example, E0 of Zn2 plus slash Zn, that is, if that value is given, that is the standard reduction potential value. How do you know that it is reduction potential? See, look here, 2 plus is changing into Zn. So this gained electron became to become Zn. So this is reduction. And E0 means potential. Standard reduction potential value will be given in the question. Okay. And if standard reduction potential value is given in the question, lower reduction potential means it is not easy to gain electron, easy to lose electron. Okay, the element will easily lose electron. Lower reduction potential easily loses electron, and which is easily losing electron will be anode. Okay, and if the element with a higher reduction potential means it is an indication that it can easily gain electron, then it will be cathode. Okay, but in this question the reduction potential values are not given. Then one more thing you have to remember, the stronger metals will have lower reduction potential. Okay, that is another indication. Stronger metal will have lower reduction potential. Then from small class onwards, we are learning the simple electrochemical series, the metal reactivity series. In that, after hydrogen only copper, silver, gold, mercury, platinum, all those things are coming. Okay, so these all are having, these metals are less reactive metals, very less reactive metals, and they will have higher reduction potential. Okay, so these many metals you have to remember, they are less reactive and they are having high reduction potential. So here you look, silver is a low reactive metal, right? So zinc will be a high reactive metal compared to silver. Without reduction potential value itself we can understand. So this metal is low reactive and it will have high reduction potential. So silver will be cathode. Okay, clear? I hope you understood. Less reactive metal will be cathode, more reactive metal will be anode. If reduction potential values are given directly, you can choose lower reduction potential anode, higher reduction potential cathode. Clear? I'll give you another example, aluminium and copper. You put pause for a second and think which will be cathode. If aluminium dipped in Al3 plus is connected with copper rod dipped in Cu2 plus using salt bridge and all, if a connection is made like this, which will be cathode? You think and say. Okay, put pause and think. So here again we can see copper is a low reactive metal. We by hearted that copper, silver, gold, mercury, all those are low reactive metal. They will have higher reduction potential. Okay, so here copper will be cathode, aluminum will be anode. Okay, so that's how we choose anode and cathode for a working cell. Then what happens if the salt bridge is removed? here the salt bridge is there. If it is removed, this connection will be incomplete. The circuit will be incomplete, right? So will there a flow of current? No, current flow will stop. Okay, it will stop working. Okay, if salt bridge is removed, the cell will become incomplete and the flow of current will stop. Then, when does electrochemical cell behaves like an electrolytic cell? Okay, so when it is connected like this, we can calculate E0 cell value for this. Okay, E0 cell value will be E0 cathode minus E0 anode. Okay, so when you calculate, you will get a value here. Here cathode is silver, anode is zinc. One more thing you have to remember, whether it is cathode or anode, we have to take reduction potential only. Don't think that for anode we will be taking oxidation potential. Anode oxidation is only happening, but you will be taking reduction potential for anode and cathode. Okay. Okay, so standard reduction potential value of silver is 0.8 volt. Here value is not given, I am just explaining. Without value also we can write the answer. Now zinc standard reduction potential value is minus 0.76 volt. Okay, so when you calculate E0 cell, which is E0 cathode minus E0 anode, you will be getting a value minus of minus plus, so 6 1.56 volt you will get. Okay, 1.5. So that is the E0 cell value for this particular cell. Okay, now when you apply a external potential greater than E0 cell value, for this question the E0 cell value is 1.56 volt. If you apply an external potential of greater than this E0 cell value, the cell will be acting like an electrolytic cell. So the point to be noted is, when external potential E external is greater than E0 cell, the cell will act like electrolytic cell. Very important point, electrolytic cell.